Hi, Lens Enclave viewers. We are going to have you investigate a project pricing so that you can get a sense as to how much to charge for a particular very risky endeavor in, say, a corporate insurance. A lot of times you are trying to model a situation, but there isn't a great distribution out there. So you have to kind of just get in there and get your hands dirty and create this distribution from scratch, but you still want to know the average. You still want to know the standard deviation, the skewness, the kurtosis. And so this little project is going to show you how to do that. We're going to start off with the mean, and the way that you take the first central moment, or the expected value, the mean, is that you take each and every value that your random variable can take, and then you multiply it by its probability. And then once you're done, think PEMDAS, you add at the end. So you multiply first all the random variables by their probabilities, and then you add. You work for an insurance company. Your job is to price this insurance product such that you can generate a sufficient amount of gross profit to make it worth your while, to make it profitable, and to consider the risks involved. So this particularly high risk activity that you are insuring against, we have these numbers. You can modify them, change them. We do ask for your benefit that you, whatever values, losses, or what have you, that you come up with, that you keep the worst at the top and the second worst and the third worst. In other words, like, make things less and less bad as you go down. And perhaps at least as importantly, here are the associated probabilities with these events, right? So like right now, we just kind of have it very naively, by the way, that just like a negative $200,000 loss for you, the insurance company, just can't happen. It has a 0% probability. Down here is where the spicy stuff happens, the good stuff. This is where you're going to set what are you going to charge for your insurance. Like, more often than not, an insurance company sells insurance, and then the thing that they insured against never happens, right? So they sort of pocket the money. It's not that they pocket the money and, go about their merry way. They have lots of loss scenarios that they have to cover, right? But they have to charge enough for their insurance so that when nothing happens, like, they have enough money to cover all the other situations. So here's what you need to do. After you've gone in and you've changed up these probabilities and events, what we're going to have you do is multiply across and add down. So we're going to put equals and the event that the random variable takes, the value that the random variable takes, times the probability that it takes that value. You are going to multiply across and then move down and add. Now, I'm a stickler for this kind of stuff, so pop back in and put that. We've broken this down into 3 different scenarios: the loss scenario, the break-even scenario, and the gain scenario. So based on these probabilities, there's a 20.5% chance of loss. And given that you were going to lose, you would on average lose $19,000. There's a break-even scenario of 4.5% and a 75%, as the probabilities are currently set, of making money. And on a probability weighted basis, that would be that every time you made money, on average, you made $18,750, weighted to probability. So across all of these scenarios, every time you sold a policy, all the losses, all the break-evens, all the gains, on average, you would lose $250 every time you sold a policy. That is the first central moment of your distribution. These are visualizations of what this looks like. What this means is you're not charging enough for your insurance, right? Like, you have to charge a sufficient amount that you would want to do this again and again. So you're going to maybe need to charge more. Let's just put in, say you charge $30,000. Maybe this is corporate insurance, by the way, like you're insuring some, highly risky activity for a CEO, and they don't bat an eyelid at paying $30,000 for this. Well, now I don't know if that's enough coverage. I don't know if that's enough of a gain, but at least it's a gain. Every time you sell one, you're generating a gross profit of $3,500. What we want you to go in and do is price this product after you have played around and maybe modified some of these values and taken a look at the probability distribution associated with the different payout structures and what that looks like on a probability weighted basis. So, yep, that's going to be the first part of your assignment, and we are clearing this out for you.